Okay, so here's a brief introduction to the package called Plots.jl, which is used to create data visualization and some mathematical plots. So we first start with the installation of the package. It's quite easy. It's just like any other Julia package. Use package.add, and here we have package.add plots. And I'm using the current version of the latest version of the package because I think there's not enough number of a tutorial that's about this latest version that is up to date, because because the syntax and the backends actually changed a little bit during the update of Julia language. So, and some other package that you might consider adding is what's called GR. There's so GR is the backend for Plots.jl, but you could also add you could also use something called PyPlot, which uses Python for its backend, but it doesn't matter too much. So to start using the package, we can start by using plots for run this, and I could specify the backend that I'm using. So for this, from using GR for this video, because so in my opinion, this is the so far the most stable and the most stable and efficient backend for plots. So we can start by trying to make a scatter plot with some random points. So we start doing this by say generating some points on the. So let's generate some random, like the coordinates of 1,000 random points following the normal distribution. And then we can make a scatter plot. So I type plots.scatter, and first it's gonna take the data as input, like x and y, but if you do this, we could create probably the easiest plot that to make, but x and y here it counts as the data that the plot requires. So it's not optional to plot something. You must have a certain object or data to plot with. But at the same time, you could add some arbitrary or optional arguments, like let's say I want to change the transparency. So I want to add alpha equals to 0.2 there, and as you see, the sum of the point in the middle becomes transparent, and you can see the depth and count the number of the plot. You could also add a bunch of other things. For example, there's no x and y labels, so I could add so this x y label, So something to note is that it doesn't have to be x and y, but x label and y label always stand for the horizontal and the x and y axis in the space of the plot. And you could adjust the foreground color. Let's change that to orange, and also you could have some background color. Doesn't look right there. Okay, I could have a dark color for this one. Okay. So these keywords are using the idea of metaprogramming, so that you could actually do you could actually parse put the expression into a function, but at the same time the expression is not evaluated, so it's waiting for the function to evaluate it, because those arguments as colors are actually the some argument that's pre-stored in the function, so it looks different. And you could, some basic thing is that you could add title to the spot. Note that in Julia, in Julia, some function that could change the contents of an object that already exists usually have this special usually have some marks here, and like plus title, or like if I run this, it always indicates that it's gonna change something in a plot. So a scatter of random points. But you could also what you could also do is I could add I could ask the different other objects, like plot and x and y. So I can connect those separate points consecutively. And for the line plot, you could use some arbitrary, like optional argument to adjust the style of the plot. For example, marker, stroke, width. Let's change that to 2, so that it looks like a little bit wider. Yeah, and it looks okay. So, the point of the problem of this plot is that we are adding the line after we are adding the points. You could do this in a reverse order, and note that what's interesting is that changing the order doesn't create an error, and those optional arguments are still going to work. So let's do this. Okay. So here's probably the easiest example that I can think of. Otherwise you could plot a sequence. But I sort of want to create this in a more creative way. Say we could have some object called P, which is plot, or plots.plot, or just plot. It's fine, because what the first part of the function is doing is that it takes an argument to say that the plot function that we are calling is it's an object from the plots package. So if you get different plotting package like Plots.jl or getFly.jl or Naki.jl, they all have the function called plot, but like we could specify which version of plot that we are using. In this case, we are using the plots.plot. But as long as you don't get other packages, the both way will work equivalently. So let's plot the sequence x with respect to the index, and okay, and we can run this code. And what's interesting is that when I run this code, it's assigning the plot as an object to the name p. But at the same time, we created a sequence. Like we actually rendered the plot. If I don't want to render the plot, we could do maybe a semicolon here, so that you could see it's still the test plot. Like no new plot has been created. But to get a better idea of what this is actually doing, let's first agree that anything can be objects. Like at least that's what the category theory told us. So I could have some type of p. Oh, sorry. Type of p. So type of p is a plot object that stores a bunch of data and options. Like if you don't believe me, you could dump p, and then you could really get the idea what is stored in the function. And if you're not too busy scrolling down the output, we can start making another plot with this. For example, I wanna add to this plot the sequence of y, and probably this is not the best way that we do this, but that will still work. So what this is doing is it takes this and store this as p. Okay, so we get both options, and to save the figure, we could say save fig and takes in p, and like p dot png, and you also gotta print where you're gonna save it. Like okay, I'm gonna save it into this folder, and this will work. An equivalent way that we could do this is to delete the p equals this one, and since we got no object storing p, and we could just forget about this. Like this, it doesn't. If I don't specify which p that I'm acting on, the save figure function and the printing function, and the print function is going to take the previous plot as a default option. That's important, and that still works. So that's tough. So that we create another plot. You could check whether this works. You could always a fancy way that you could check this is to do this by changing the style. Okay, I'm gonna take in no other values, no other data, just to change the plot and see if just to change the style of the plot and see if it actually works. Yes. So here's another plot with the new kind of idea. So a good way to do this is to remember a bunch of plotting function, and remember a bunch of attributes, or I don't know how to pronounce this properly. Attributes, and just remember a bunch of these arguments to get an idea of what they stand for, so that you could memorize them without having to look at the menu over and over again. But there's several functions that you can't that I think it would be convenient to recite them. For example, mesh version. Um, so, for example, the contour. We'll get into the problem of meshing and the perspective things later. Like I've actually written a tutorial about a series of tutorials about this on which is meant to be on Gitbooks, but later I want them to be contained in a Julia Markdown file. What's great is that we can actually have some matrix and plot the contour of the matrix. I'm just creating an easy example there to demonstrate how this will work. Okay, so something we should see is that each line stands for a region that has the same height. But what we can also do is to make a field contour with colors, so that the band on each color stands for the same reason. Stand for the same region. And one thing important to remember is that the contour plot can take matrices as functions. Can take matrices as function inputs. But before creating this, we always got to make sure that which direction it's working on. So we could easily check this by an example, say like a zero region in the center, so that we can get an idea. Right. So on the contour plot, the horizontal axis or the x-axis still stands for the column or the row-wise data that we store here, but what is different is that on this direction, on the vertical direction, when we get things mapped on the y-axis, the order is actually reversed. As if you could think of x-axis as x-axis as a value of which column this plot is showing to this plot is showing off the matrix. And you could think of values on the y-axis as the axis as something that indicates which row the data occurs, so that we get one on the first column. We got one on the first row and 3 on the third row, and we got one from here in bottom and three up here. And this works similarly with Nash or with I think there's something called Nash. I'm not Mesh. Sorry, and that Mesh is maybe we'll do this maybe we'll do this in a later video. So this is what we this is what we want to make make sure about, so that we do not map to the object onto the plot with incorrect dimension. And what about 3D plots? You could say plots x, y, z, and it gives you a 3D curve, a 3D line segments that indicates the path that we are drawing. Or you could do plot scatter. Okay, so the plot and plot scatter automatically recognize how many data inputs that you have, and so that you can make a better plot for you. Like so that you could recognize which feature you are using. In this case, I'm using a 3D plot option. I'm using a 3D scatter option, and Plots.jl all do this all automatically, even with complex numbers. Like let's say I want to do the scatter plot with 3 entries. Say my x value is 1, 2, 3. My y value gets a little bit fancy here. We could have 1 plus 2 times IM. Note that it's the IM that stands for the imaginary numbers here, and 3 plus maybe minus 2IM, whatever. I'm just coming up with a dumb example. So this should actually work, and you can see that it's automatically decomposing the data into the imaginary value or complex value, and this is especially like useful when you're plotting things from differential equations and spirals or Fourier analysis with Fourier transformation or like something like some spectrum, and this could be kind of useful. But the idea that enables Julius to do this is the idea of functional programming and multiple dispatch options. So for something more related to mathematics, there's something called Plots Quiver. So what Plots Quiver does is that it enables you to draw arrows. For example, I get 2 points, so I'm creating a new line there. So the first entry should be the x value, x grid, and second y, and the length of arrow of x, the length of arrow, actually I forgot. Let's try this for the example. Okay. For y is on 1, 1, and what I do remember is doesn't. We should make sure that they are in the same does it work? Array 2, so we could wait, actually what happened to okay, oh sorry, quiver. This so I'm adding this tuple. Oh, sorry, I'm adding this tuple here to indicate the starting from large to one. So let's say the 2 exponents are using the first one is 0. Sorry, the first argument is 1, 1. So this is 1, 1. The second argument is 2, 1. So x equals 1, y equals 1. So it starts from here. So we are drawing it's showing me if I get a multiple entries on x, multiple entries on y, is gonna create more than 1 arrows at the same time. So the quiver actually, what the quiver actually does is that it takes let's say it takes a set value to indicate how long how long the data will be. So from here we get 3, 4. So it's mapping the first x and y to actually get the length of this value. So 1 plus 3 we get 4, and 4, like 1 plus 5 we get 6. So it's the quiver actually stands for the x and y deficits of the from the that we can calculate from the 2 points. And similar to that, we could create multiple plots at the same time. Yeah. So what we could do is to create another set of let's say x1 is still a random vector, and y1 is, and yeah, here. Let's actually just so this should be another set of 1000 random points, but there's an option to create multiple scatter plot at the same time. It's just by using matrix. So my x data. So let's call this whatever x. My x data have 1000 row to column, and y contains let's just initiate this with the same value. Okay, so it's 1000 by 2. So each of them are 1000 by 2, and we get x, the first column of x, the first oh sorry, that's a row. The column of x is the value of x, and the second column being the value of x2 or x1, and we could do similar stuff to the other two data sets. So we could get y and z. Alright, so okay. So z1 is, oh okay, sorry, got it wrong. There. Okay, that'll work. So to plot these, we use plots.scatter, and instead of using the function to add the points later, we can like construct this with one line of code. So y data and z data, and basically it's gonna alright, did something strange here. So they all line on the same line. Plots scatter. We could have x from here, z, y from here, z from here. Rerun this. I get it. I get it. So let's create these problems. Okay, so what it's actually showing us is that what it's actually showing us is that it creates it plots the scatter onto the screen at the same time, but it automatically assign a value, assign a color to each column, so we get y1 and so that we can get variable 1 and variable 2 into of color blue and orange. However, it is not working properly, I think. And I think the problem is with the generation of the problem. I think the problem starts with generating those polygons. And as you see, the advantage that we get from Plots.jl is that we can create plots easily from verify code and code. And also, most of the time, we use version like this, works But the bad thing about Plots.jl is that it's not going to tend to really first polish. Because usually it's actually just in time based since algorithms are just in time calculation. It's task calculation after the code, the package takes a long, it takes a lot of time. And that's why sometimes we don't wanna have this problem. Okay, so that's so far that's I think basically all we have to know about Plots.jl to create some very basic plots. I showed some more stuff in the next tutorial.